Herzlich willkommen zur ersten Ausgabe von Open-i. Bitte begrüßen Sie unsere Managing Director von NZZ Connect und Gastgeberin, Corinne Blesi.
Ja, liebe Gäste, ganz herzlich willkommen zu Open-i, unserer neuen Innovationskonferenz zum ersten Mal in Zürich. Viele von Ihnen waren jeweils treue Gäste unseres Swiss Innovation Forum in Basel. Aber auch bei Konferenzen ist es so, die kommen manchmal auch ein bisschen in den Herbst des Lebenszyklus. Und das hat uns veranlasst, das Thema Innovation neu zu denken, in einem neuen Kleid, mit neuen Formaten und auch an einer neuen Location. Was möchten wir mit Open-i? Wir möchten Wissenschaft und Wirtschaft miteinander verbinden. Ich glaube, es ist ganz wichtig, dass in Zeiten des schnellen technologischen Fortschritts die Synergien zwischen der Wissenschaft und der Wirtschaft noch besser genutzt werden. Dass innovative Ideen in tragfähige und erfolgreiche Geschäftsmodelle umgemünzt werden können und dass sich Wissenschaftler vermehrt mit Unternehmerinnen und Unternehmern austauschen. Wir machen das über die nächsten 1,5 Tage mit über 80 Referenten, mit 90 Ausstellern und mit über 1000 Teilnehmenden. Und wir freuen uns ganz besonders, weil wir eher aus dem Unternehmertum und dem unternehmerischen Umfeld kommen, dass wir mit der ETH Zürich eine ganz tolle Partnerschaft lancieren konnten und dass sie entschieden haben, ihren ETH Industry Day hier im Rahmen von Open-i heute durchzuführen. Und ich möchte mich ganz herzlich bei Janine Bio und ihrem ganzen Team bedanken für die tolle Zusammenarbeit in den letzten Monaten. Ich glaube, so macht es Spaß. Wir haben hier auch etwas Neues, Innovatives geschaffen. Und Sie bringen die Wissenschaftlerinnen und die Wissenschaftler mit, wir die Unternehmerinnen und Unternehmer. Und ich glaube, so können wir zwei Communities miteinander verbinden, wo hoffentlich Neues entsteht, wo sie sich inspirieren lassen können und wo hoffentlich auch viele Ideen weitergetragen werden können. In diesem Sinne ein ganz herzliches Willkommen. Seien Sie offen, lassen Sie sich inspirieren. Wir haben eine tolle Netzwerkzone mit ganz vielen innovativen Projekten. Dann kann man sich auch ein bisschen austoben und gedanklich in die nächste und übernächste Geländekammer schauen. Und in diesem Sinne ganz viel Spaß. Und ich glaube, ich übergebe an die Moderation. Sarah Andrina Schütz wird uns heute durch den Vormittag führen, hier auf der Circle Stage. Bitte einen warmen Applaus. Danke vielmals.
Natürlich, auch von meiner Seite her. Guten Morgen miteinander. Herzlich willkommen hier im Kongresshaus Zürich. Wir haben es eben gehört, zu 1,5 Tagen, also ganz im Zeichen des Brückenbauens. Building bridges between industry and ETH to foster joint innovation. Also, tauchen wir doch gemeinsam ein, oder? In neueste Forschungen, entdecken vielversprechende Technologien und natürlich, ja, wir lernen auch spannende Start-ups kennen. Der ETH Industry Day, also zum ersten Mal im Rahmen der Innovationskonferenz Open-i. Das ist eine Premiere, das ist ein Novum. Und auf das freue ich mich ganz speziell. Mein Name ist Sarah Andrina Schütz. Lassen Sie uns also gemeinsam lernen, gemeinsam in die Zukunft blicken. Und bevor wir nun also ganz offiziell mit dem ETH Industry Day beginnen, noch einige Informationen zur Schweizer Innovationsplattform Open-i. Wir bespielen ja, das haben Sie bereits schon mitbekommen, zeitgleich verschiedene Bühnen. Es wird also so einiges geboten. Wir haben es eben gehört, fast 80 internationale Speakerinnen und Speaker, verschiedene Erlebniszonen, zum Beispiel eben hier draußen, das haben Sie gesehen, als Sie reingekommen sind. Und ich würde mal meinen, es wird uns heute garantiert nicht langweilig. Kurz, wir bringen heute diese innovativen Denker, die MacherInnen zusammen, um eben den Weg zu ebnen für Kooperationen, die die Schweiz als innovativer, als erfolgreicher Markt auch wirklich sichern. Und das ist unser Konzept, unser Ansatz, setzen wir auch gleich um, zum Beispiel eben im Rahmen des ZHW Industry Hacks. Das ist ein 24-stündiger Design-Sprint, wo eben die Next Generation, diese New Talents an ganz spannenden Konzepten arbeiten für top-aktuelle Themen. Oder aber Sie haben sich vielleicht auch selbst bereits für eine Innovation Lab angemeldet. Wenn ja, dann sehen Sie diese Information auf Ihrem Badge. Für Kurzentschlossene gibt es teilweise auch noch Plätze. Also ganz proaktiv mit dabei. Das Wichtigste ist, Sie können sich Ihr Programm ganz persönlich für sich nach Ihrem Gusto zusammensetzen. Und das machen Sie am besten, wenn Sie die B2Match-App auf Ihr Smartphone laden. Also auch hier wieder full of innovation und wirklich auch Features. Darauf finden Sie zum Beispiel eine KI-Übersetzung oder aber eben auch die Möglichkeit, Ihre Fragen für die Referentinnen und Referenten einzusenden. Oder Sie organisieren sich gleich ein One-to-One-Meeting mit anderen Gästen oder dann eben auch den Speakern. Also laden Sie sich unbedingt diese App auf Ihr Smartphone. So, and for this year's conference, we have chosen to hold all presentations and discussions in English. So feel free to scan the QR code just right behind me for AI-generated translation directly on your smartphone, or just follow the link in the B2Match app. Since we're working with a very tight time frame today, we encourage you to dive deeper into the discussions with our speakers right after the presentation in the exhibition area or right at the speaker's corner in the breaks. All right. And now, let's officially begin with the ETH Industry Day 2024. And it is my pleasure to introduce Janine Biu. She's the head of Industry ETH Partnerships for Innovation and holder of diverse board mandates. Bitte schön.
Welcome everybody to this ETH Industry Day. ETH, what is this? More than 25,000 students we have at the moment, and we have 567 professors that are working for ETH with all their teams, etc., etc. And today we do want to show you what is exactly happening at ETH in the whole research area. What are the ideas of the future and how is this going to work in knowledge transfer with you? Because the very important thing is that a university is never just an island that is basically producing and in the end people go out and work and start from scratch. No, there is a lot about collaboration, how we can work together, how we can take care for having innovation very soon with your companies and also starting to do research together. And this is what you see today. You not only have I say, smaller part of the people that are really doing research at ETH here. No, you have the whole day also our exhibition where you can experience these innovations, but also what's happening and how and why this is important for your company. The ETH Industry Day we used to have up on our campus at Hönkerberg, but in the end we saw it's a stress for everybody. It was not only that we were very limited in the time frame when we could do this, because we only could do this when there was no semester, because otherwise many students, I remind you. But on the other hand, we also did not have this kind of space in the middle of the city and also enough space to do our exhibition. And therefore, this kind of collaboration is very, very important for us, also to open a window to you to show what's happening at ETH. In that sense, I thank NZZ Connect, Corinne, and also all the team from ETH that was working all year long to really make this happen with everything you have. Please take the opportunity, experience this, look at all the things, start thinking and discussing with all the people what is new, what will move us within 5 years, within 10 years from now. Thanks a lot for being here. I'm really, really thrilled to start this now and experience together with you this day. Thanks a lot.
Thank you, Janine, for the opening remarks. Okay, let's dive straight into today's program. Up next, we'll focus on our 4 main topics, which are AI and robotics, health and food, processes and materials, and sustainability and construction. So each session will feature a case study, followed by a short discussion, and then it's time for our fast-paced pitch round on the overarching topic. Also auch hier wieder, ich habe es ja versprochen, dynamisch wird garantiert nicht langweilig. But now, to kick things off, it is my pleasure and honor to introduce Matthias Rebellius. He is the CEO of Siemens Smart Infrastructure and the member of the Siemens Management Board. Under his leadership, Siemens Smart Infrastructure has been driving innovation that connects energy systems, buildings, infrastructure, industries, helping create smarter, more resilient environments. Ladies and gentlemen, please give a hand to Matthias Rebellius. Good morning. Hi. Join me here on stage. Matthias, thank you for kicking off the ETH Industry Day. ETH has been partnering with Siemens for more than 20 years. That's incredible. You made the time to be here today. So why do you believe the partnership between ETH and Siemens remains so important?
Yeah, in general, it's important to have, because in Switzerland, we are not known for natural resources, we are known for brain power. And brain power is linked to the world-class universities, but also the industry and the startups we have, the many small, very innovative small, medium enterprise, and the large conglomerates and companies and industrial companies who work together in this network. And that's, of course, important for Siemens. And for me personally, as a graduated engineer as well. And we have more than 6,000 people in Switzerland. We have a headquarter, my headquarter for smart infrastructure, right in Zug, in the center of Switzerland. I shouldn't say that in Zurich, right?
It's okay.
But important, with more than 500 engineers and very impressive, innovative stuff.
Great. So thank you very much for your perspective on this. All right, we're looking forward to you opening a keynote. I would like to give the floor to Matthias Rebellius, please.
Thank you, sir. Yeah, good morning, everybody, from my side as well. It's really an honor for me to speak here as an engineer for almost, I would say, 40 years ago. I've now made my way through the different industries. And to all that time, innovation was really at the heart of what I was up for and what we are delivering. But here today is really a great honor for me to be. And also in the Congress House, which is nicely built and refurbished, and also lots of smart Siemens equipment in there, creating comfort and safety. And I hope we don't need the evacuation system today, and everybody stays safe throughout the conference and can enjoy also the nice environment. We are here and talking about innovation and innovation for the future. And the future has never been that important, but also disrupted from trends and challenges that we see, talking about climate change, urbanization, the demographic shifts, geopolitical tensions, and I don't want to talk about this today, but there's a critical need to develop new approaches, new business models driven by innovation to tackle these enormous challenges. These are existential questions, and any technology solution must scale to have a chance to cope and to create an outcome for society. When it comes to build alliances, like what we talk here today, there's only a few better partners than the best universities in continental Europe, and the ETH Zurich is definitely one of those, has a stellar reputation, not only in engineering and also in architecture, built environment, data structure, but what I did not know is also a top-ranked university in earth and marine sciences, geology, geophysics, and alike. So there's lots of different perspectives to take, and this is what sparks innovation if we do it right. A twofold expertise is also understanding the world as it is and seeing the possibilities to shape it into a direction, and that makes the ETH a very valuable partner for Siemens, for industries, with long-standing partnership. Together, I counted almost, we are now, as you are celebrating 170 years, we have together more than 350 years of innovation and spirit. If that does not make a difference, who else could? It's also about purpose. So one driver for innovation is, of course, for us, the pressure to stay ahead of competition. But it's also that the ETH president, Professor Joël Meissot, has also to account to his stakeholders, perhaps not shareholders as I have, but the stakeholders, to live up to that, and this is really happening. So given the state of the world, we must set the higher targets and also look beyond profitability only or university rankings and work together for the purpose of making a difference. Technological innovation is a powerful lever for tackling those challenges, and we must mobilize the potential for sustainable change. In industry and academia, invention for its own sake doesn't make the trick, and it's also not fun. It has to create a purpose. Werner von Siemens said once, almost 160 years ago, so some things remain the same, ideas as such have very little value on their own. The value of an invention lies in its practical implementation. That's still true, right? Now let me ask you here a question. So please raise your hand if you heard about the Heron of Alexandria's Aeolipile, or easier to pronounce, the Heron's engine. Anyone heard about this? Or shy, what would be the next question? No. It's a perfect example, of course, and it's not well known, which is already the proof point that this invention has never led to an innovation. And you see it here. It is a functional steam engine concept recorded in the 1st century Anno Domini, was never harnessed for work, it's more like used as a plaything, but it is a first bladeless steam engine. And could you imagine the impact this could have had in earlier days if someone would have drawn this invention into an innovation? So an innovation must be applied to serve society, meet real-world challenges, and we have enough of those today, as I was talking about before, to enable sustainable ecological, societal, and economic life improvement. Technological innovation alone is not sufficient. We need technology with purpose. This is how we call it as Siemens, and this is also what we are committed, and our technology is everywhere. It's behind the scenes, like here today, but also when you travel in factories and shopping malls, offices, data centers, it's everywhere supporting a purpose to make life more sustainable, more efficient. And we do this with, of course, technologies from yesterday, today, and tomorrow. And talking tomorrow, and OpenI will talk about AI, of course, a lot these days, as everything will be ingrained, as digitalization enables sustainability, as also universities enable us with their perspective to help to define a purpose of innovation, to spark new ideas, because if you are in your silo, you come to the same ideas just in a better means. But you need to take a different perspective to foster innovation. Given the challenge of climate change and the purpose of transformation, everything must become more sustainable and resilient, but at the same time remains competitive, because also that is a topic that we here in Switzerland, in Europe, have to strive for, be the best, remain to be the best, have the fighting spirit to be the best in the world to solve these problems. This has to be our ambition. But how? By harnessing innovation to combine the real and the digital worlds, which means we have the digitalization as the accelerator for development, for implementation, and of course communication between machines and people and the world. Gives us increasingly powerful tools. So how do we leverage those powerful tools? One example is a digital twin. You might say, okay, we are talking for this since decades. But a digital twin has come to life in the last couple of years, and it's really exponentially taking up. And it's the approximation of the ideal state, constant alignment of the real and the digital worlds to make the real world better and consume less resources. And we can apply digital twins to products. We can apply it to machines, to production lines and processes, or to the entire energy system, or to the electrical grid. In Nanjing, China, we constructed the largest manufacturing plant in a greenfield for us. And we built it twice. We built it once in the virtual space, then in the real world, and then we combined both to, over the life cycle, make it continuously better and cope up with the changing environmental conditions and the challenges. What will be the next big thing? After the digital twin, we are talking about the industrial metaverse. The industrial metaverse is, together with AI and IoT, the connectivity of everything, creating a form of an industrial metaverse. What is that? I have a definition here: a shared, immersive, persistent, physics-based digital space where humans, machines interact with one another and with data enhancing the physical world as much as replacing it. So that is I thought if we are here at academia environment, I need to bring also a real definition of what it's supposed to be, because it could be pretty fuzzy also what it is. But more importantly than the definition, we need to make a stepwise improvement to drive efficiency, competitiveness, and innovation within the industrial metaverse. And there's business cases that are gaining traction. Started with ideas, and now we're working together also in implementing more AI with partners, also some of them here in the room, to implement this in our value chain. For R&D innovation, for model-based systems engineering, also for being faster to market with better simulation skills, planning of manufacturing processes, reducing material cost and resources, by the way. Something that has not to be built twice in real saves 50% of the resources, as you know, and the cycle times. So last month, ETH and EPFL founded a new Swiss National AI Institute, as you might know. At Siemens, we welcome this new initiative. We will support it, and we will also contribute to this, because the importance of AI for industries cannot be overstated. ETH, Siemens, we share the aspiration to remain innovation leaders in Switzerland, but also globally. We have also collaborations in Singapore and around the world. There's more we can do and more we have to do, because innovation these days is not a play of one single individual. It has to be a team play, and this is why I appreciate so much, and you will do it outside to collaborate, to exchange ideas, and also innovation needs agile environments, and here I'm not talking only within the development teams. So we benefit as a company from cutting-edge research and insights, from education, training, having interactions with also students working with us or doing their PhDs or their master studies with us, and we can learn and always bring new talent and new spirit also and mindset into our workforce, which is so important because what I learned at university 40 years, no one cares outside of a museum. But it is important to learn how to learn and to be open and continuous learning. This is also what we call the lifelong learning, which is important for employees. And this doesn't go without the connection to universities and research. Now, what are we concretely doing? We have hundreds of projects between the universities and here ETH and Siemens over the last years. But I just want to call out one, which is what was the initiative for novel gas mixtures for electrical insulation. So it's not about AI, but it's still important. And why is this? Because gas-insulated high voltage, medium voltage switchgear, they operate with sulfur hexafluoride, which is SF6 gas, which is one of the most potent greenhouse gases in the world. It's of course capsulated, but during the operation or during the process and operations, there might be leakages, or it has to be recycled at the end. It has a global warming potential of around 23,000 times of CO2. So that is a big important lever to reduce in the atmosphere. And we are doing this with our products that we have now already 1 or 2 years on the market, SF6-free gas insulated switchgear. So this is how an idea or an innovation from a university brought it into a product also from other empires, but we were the first ones due to our close relationship. So to recap, also knowledge ecosystems, very important. Innovation must be purpose-driven and geared towards increasing competitiveness, resilience, and sustainability. We cannot, or perhaps some can, but we can't, research just for the sake of research. We have to create a purpose, we have to create a competitive edge, and this will then also create jobs and also prosperity in Switzerland and in the company, and also across Europe, because this spans outside in Switzerland a lot. AI, IoT, and digital twins are bringing the convergence of the IT and the OT world, which is important, and I think this is the sign of how things get closer together, and this is also the reason why no one can do it alone anymore. So we need knowledge ecosystems, which is also between industry and research, and a collaboration amongst those, and also among industry partners, by the way. We are not only competing, we are also collaborating. And we do this at Siemens. We have so-called 16 local Siemens research and innovation ecosystems around the globe, including 75 universities, and ETH is a key pillar for the research and innovation ecosystem Zurich, Switzerland, Greater Zurich in Switzerland. And the partnerships fuel our innovation pipeline. We do research applications, industry exposure together. So that is a real-life example, and we are protecting also intellectual property. So that has changed. Also in the world of data and AI, the protection of intellectual property is becoming more difficult, but still important. But I think the definitions are much different than they were in mechanical or in purely electrical times. And now let me close and lead you into the great examples that you will see in the following presentations and outside also at the exhibition. Looking forward to that and fostering this. Let's join forces in spearheading a new era of sustainable innovation, with scientists and researchers play a critical role in shaping a better future. Collaboration with industry and pioneering groundbreaking solutions, because if we want to achieve our targets for 2030 and 2050, the net zero planet or net zero companies and countries, it won't go with the technologies which are here today. But they are important for the next 10 years. And the good thing is we are continuing together to develop the technologies which will help us also in 10, in 20, and in 30 years to make a difference. I'm very optimistic and if we remain mindful of empowerment, importance of sustainable technology as a business imperative and not just as an option for consideration. Thank you very much.
Thank you so much.
Thank you.
Thank you. All right, now let's dive into our first main topic, which is AI and robotics. So how can robots and humans work together? ETH Zurich and Microsoft researchers use mixed reality devices to make human-robot interaction simple and intuitive. This will allow robots to learn from interactions with humans and perform more complex tasks. So we've prepared an intro video for the case study with the title Human-Robot Interaction by using mixed reality devices. Sounds thrilling to me. Film up.
How can we combine the capabilities of robots and humans? Mobile robots provide automation in many industries, such as manufacturing and logistics. And often, they only bring things from A to B within a factory or a warehouse. They can't do more complex tasks on their own. And so our collaboration with ETH seeks to use mixed reality to enable humans to help robots do more complicated tasks in unconstrained environments.
With our research, we're trying to enable non-expert users so they can make use of robots, for example, via natural gestures such as hand gestures or voice commands. For this, mixed reality devices such as the HoloLens are an excellent interface because they allow us to share a common understanding of the world with the robot. With that, we can then attach tasks to real-world objects, or we can visualize what the robot is currently seeing and planning. For complex systems or novel tasks, robots cannot yet figure out everything by themselves. So that's why we're working on methods that let us intelligently combine human intuition with the robot autonomy. For example, we can then help robots that got stuck while carrying a heavy payload through a door, or we can visualize what they were planning and make adjustments before we give them the good to go.
With mixed reality, human-robot interaction becomes easy and intuitive. And in our vision of the future, mobile robots will be able to learn from their interactions with humans to eventually do these complex tasks fully autonomously. And from Microsoft, we are hoping to incorporate these innovations eventually in products for our customers.
All right, ladies and gentlemen, please give a hand to Jeff and Florian. Please. All right, so let's take a closer look at the case study and most importantly on the cover, the why behind it. So we'll ask some short, focused questions to get to the heart of things. But before we dive into the technical details, let's start with something a little bit more personal. So gentlemen, let's break the ice with a quick question. If you could have a robot handle one daily task for you, what would it be? Jeff.
So I love to cook, but I'm pretty bad at multitasking, and so whenever I cook a recipe, it takes twice as long as the recipe says it should. So I'd love a kitchen assistant to help me out.
Good choice. Love it.
I have 2 little kids at home, so they always leave a mess, and I would love robots that can clean up after them at home. But also, like, my wife probably wouldn't let me buy a robot just for that, so I would love a robot that can also learn new things and like have multiple uses at home.
Perfect choice. All right, let's move on to the big picture. Understanding who will benefit most from your innovation is always key, of course. So, Jeff, where do you see possible applications for collaborative robots? And you've mentioned unconstrained environment. So could you explain what are these exactly?
Sure. So let me start with the second part. So if you think about where robots are used most commonly in industry right now, it's often in factories or warehouses, and robots can be effective, for example, on an assembly line because the parts that they're working on are in exactly the same place every time, and so they can just make the same movement over and over. And in the real world, things are not so structured. Things are not where they're supposed to be, or unexpected situations happen. And so what we can do, and what we've highlighted in this video, is if we can share some of the human intuition, so the semantic and spatial understanding that we as humans have, which we do quite easily, if we can share that with robots, then we can help them to do more complicated tasks in environments like the home or in the workplace, where they may not, it would be difficult to program them to handle every single task, but if we can teach them in those environments, then they can do more to augment human capabilities. And that's where we really see, or at least my perspective, is that in the future, rather than having robots take over human jobs, really to work alongside humans and augment our capabilities.
Got it. Academic projects and industry collaboration often push the boundaries of innovation. So, Jeff, why are academic partnerships essential for advancing these technologies, and why was ETH chosen as a key partner for this work?
Yes, so my group at Microsoft is actually a bit special. So my boss, Mark Polyface, has two different roles. One is directing Spatial AI Lab at Microsoft here in Zurich, but also he's a professor of computer science at ETH. And so through that situation, we have very deep ties, not only to his university research group, but more broadly across the university with many academic collaborations, including this one. And that benefits both the students that we can support in their research, doing things that we probably would not be able to work on internally, things that are more open-ended or forward-looking. And we benefit from that as well, because the innovation ecosystem here in Zurich is so rich, with both the university, many innovative startups, and large tech firms. We don't have to go far to find academic collaborations or strategic partnerships, and so leveraging that here is really important to us.
So Jeff mentioned it, there are still some challenges, let's call it room for improvement when it comes to robots performing complex tasks. So Florian, why are robots still not capable of handling these more advanced tasks, and what kind of time frame are we looking at when we're talking about the ready-to-market products?
So there's a saying, hardware is hard, right? Everything that has to do with multiple components that need to work together correctly is not an easy problem in and of itself. And we've seen a lot of developments in hardware over the past couple of years. We have now drives that have higher torque density, are more back-drivable, have self-sensing capabilities. So we now have very capable hardware. And I think currently we're working more on the software layer. We have seen great steps towards autonomous robots with reinforcement learning technologies. We have better physics simulators, so we can actually now kind of build the software layer. But I think also importantly, and this is a little bit what we have been working on afterwards, there's a whole layer of giving this into the hands of real users and having user adoption as well as regulation. So even if we have the hardware, have the software, there's still multiple steps to be taken until we have robots at home. And so in fabrication, like automation scenarios, we already see robots. For example, Figure has deployed humanoids now with BMW, at least in a little test case. But I think for home automation, probably not this decade, if next decade even.
Good, we heard that loud and clearly. Okay, so let's talk about the user feedback. What's the user feedback so far? I mean, do they enjoy this very natural interaction, intuitiveness when working with these devices?
Yeah, there's something really special about like just being able to interact naturally with a robot and it mimics you, or it does something that you kind of tell it to do in natural language, and people really enjoyed that. They kind of had these playful interactions also with the robots. But more importantly, there's also the aspect that when the task becomes very spatially complex, if you need to do 3D interactions, you're very limited by traditional devices like tablets or like a mouse and a keyboard. So we saw in these kinds of tasks that it's really helpful to have this spatial immersion. And we also got that feedback from a lot of our study participants that they felt more immersed. So there's also undeniably still a training effect. For new users, it wasn't super easy to use out of the gate, but that also is encouraging for us. That means we have more research to do to make these systems more natural and efficient. Yeah.
Great. So thank you so much. Ladies and gentlemen, we're acting here with a very tight time frame, so we encourage you to go deeper into the discussion with Jeff and Florian later in the exhibition area or right at the speaker's corner. So please give a hand for Jeff and Florian. Thank you. Vielen Dank.
Thank you.
So a very, very clear message to all of you, ladies and gentlemen. Please don't hesitate to approach the researchers, the entrepreneurs. Collaboration is truly key, and it is truly a win-win situation for everyone. So whether if you're in the academia or you're part of Switzerland's economy, I mean, this cooperation really paving the way for groundbreaking progress. And now it's time for our fast-paced pitch round in the field of AI and robotics. And here are the rules. Each participant has only 5 minutes to introduce you to their research and innovative solution. So every speaker has their own introduction. Ladies and gentlemen, please fasten your seatbelts. Great innovations are coming up.
Benjamin Grew and his group are researching the key principles by which brains function and trying to incorporate these into artificial systems that interact intelligently with the real world. He has focused on brain research since completing his PhD at ETH in 2010 and deepened his knowledge of neural networks and how memories are stored in the brain at Stanford. Grew has been a professor at the Institute of Neuroinformatics at ETH and the University of Zurich since 2016 and is co-founder of the startup Alpine AI, which offers a Swiss version of ChatGPT. What are the advantages and limitations of large language models like ChatGPT, Benjamin?
All right, welcome. My research life in 5 minutes. My name is Benjamin Grew. I'm a professor at the Institute of Neuroinformatics, that is us. And the mission of our institute is very specific. We try to understand how the brain works, how the human works. Why are humans capable of solving all these complex tasks that we just saw? And then the idea is to derive principles and to bring these back into algorithms, into better language models, into robotics. And today I'll show you a little bit, starting with a comparison of deep learning language models and the brain, why this is a useful thing to do. So here on the left side, we have a classical deep neural network. This is your ChatGPT. This is your robot controlling algorithm, right? And we talk here about deep neural networks. Maybe you've heard transformer networks, language models. I group them under this thing. And these systems are remarkable in what they can do, but they still have a lot of limitations. One of them being they use a lot of energy, right? You have heard the recent discussions. Microsoft is now buying power plants, right, to power their data servers, right? Thousands of GPUs running just to power large language models. 10 to 20% of energy consumption is projected to be just in the US, right? Just these data centers. These algorithms, to train them, use huge amounts of data, right? ChatGPT was trained on text data of the whole internet, right? I haven't read the whole internet. You maybe neither, and I think we're still smarter to some extent. still these systems are hallucinating, right? They're statistical methods. They generate the next word, but they do not really understand the physics of our world, right? And another problem, they cannot continue to learn. We just had it, right? Humans should do lifelong learning, right? We should learn new things every day. These machines can't do it. They get basically deleted and then trained from scratch with a huge new data set. On the other hand, and that's what we are interested in, we have the brain, right? The brain is remarkable. It's much better in learning. Just think about, how energy efficient the brain is. 20 watt, right, is what our brain uses to power millions or billions of neurons and to learn. At the same time, we learn extremely efficient, right? My little kids don't need millions of pictures of dogs and cats to differentiate these two things, right? To learn language. They don't need to read the whole internet, right? So there's something about the brain that's very efficient. And the brain learns a physical model of this world, right? I understand if I, drop this remote, right, then it falls to the ground. I understand this, and I then can express this in language, right? But I have an understanding of the world, and then I use language to express it, not the other way around. This is what ChatGPT does, right? And we do continue learning. I hope that you learned something today, and that when you learn something tomorrow, you wouldn't have forgotten what you learned today. Okay, good. So we take inspiration from here. I already mentioned ChatGPT. It's remarkable. We are at a level where ChatGPT has similar amounts of neurons as we have in the human brain, right? We have here 30 to 70 megawatt to train it. That's a single, generator power plant that you need. So this problem we can overcome. There's new research also at our institute. It's called neuromorphic processors, neuromorphic hardware. You may have heard about this. These are computer chips that, similar to the brain, have like neurons that, spike and send information digital. And these chips are on the order of 10,000 more energy efficient than a GPU, right? Problem is, we make these chips, they're like the brain, we just don't know yet how to train them perfectly, right? So that's the learn algorithms we don't know yet. The second problem is, I already mentioned, we have these huge amounts of training data, right? And I would argue here that to make this more like the brain, there's also one thing missing. We don't really know which architecture should we train, right? How should this look different from this language model architecture, from the transformer architecture? So if we would understand how the brain learns and how the brain learns continuously and how the brain learns a physical understanding of the world, then we could take these principles and build robots that do this. And this is an example of a first of such technology. This is in collaboration with Robert Kutschmann, who built this amazing robotic hand here. This is a student of mine, Elvis Nava, who now started a startup, Mimic, a very cool startup. And so the idea here was to train systems, embodied systems that interact with the world, and by that learn, right, the consequences of their action. And by this you learn a model of the world. You learn what happens if you drop things to the floor. Right? And we hope that these systems, somebody mentioned a kitchen assistant, right? This is close, right? We're getting there. Give us a few years. So I am almost a little bit too fast, but I think I leave time for the other speakers, yes. So that was it. Thank you for your attention, and I hope you enjoyed my talk. Thanks.
Our next speaker, Marco Hutter, is Professor of Robotic Systems and Director of the Center for Robotics at ETH Zurich. He develops robots with legs, mobile manipulators, and autonomous excavators for use in harsh and demanding environments. After studying mechanical engineering at ETH, his career has continued mostly at ETH, with brief detours to industry and Stanford. Marco is co-founder of several ETH startups and recently also became Senior Director Research of the Boston Dynamics AI Institute, which is part of the Hyundai Motor Company. What partnerships with industry for innovation in robotics are possible with your center, Marco?
So together with my team, I work on mobility and interaction solutions for systems that can work in our daily environment, in the most harshest situations that you can think of. We're building solutions that can go to mountain peaks, robots that can work underground. We have systems that support us in search and rescue operations, that do industrial inspection, work in nuclear power plants. And I believe in the not so far future, we're going to send these robots or similar robots also to space to help us for exploration on Mars or a moon. Now, if you look what is under the hood of that, these robots today, they're all controlled by AI. We're training these robots using simulation-based data generation together with reinforcement learning in order to create a neural network that in the end takes the observation of the robot, what it sees, what it feels, and directly commands the actuator commands. And we do that like in a game. So the better the robot becomes, the harder we make the challenges, until we have the skills that allow these machines to operate in pretty much environments that we face in our daily world. And if you do that, we get pretty amazing mobility skills. We get robots that are able to get across almost arbitrary environments, and that has been accelerated in the last couple of years drastically. So we're going to soon have machines that have the mobility capabilities of humans. Put a box in their way, they will find a way to get across that. And if you're looking how these robots are doing this, it's actually pretty natural. So they go there, they touch it, they prepare, they jump off, they use their limbs, their knees, their body to get across it. And if the box is too high, they're going to take a ladder and they will go beyond that by themselves. Now, what I show you here in a very simplified example of a quadruped getting across different environments, that is technology that we're using in all kinds of different systems. Systems that have different morphologies, legs and wheels. Systems that are equipped with arms that can play tennis against you. But also a big construction machine, excavators, think about forestry machines. They're all controlled with the same technology. And if you heard what Benjamin said before, if you're combining this now also with this general level intelligence, this common sense that we're seeing, I believe it's pretty clear that kind of robotics is the unavoidable future for our society and economy. And robotics is not something that only happens in research. Robotics is something that is very close connected to industry. That's also how we are living it. We're having a lot of collaborations with different industries. We use this opportunity to understand the problems and at the same time come up with insights, ideas. We train the right people with the right skills and potentially even with solutions. Solutions that can be either absorbed by industry themselves or if they're not capable yet, we create the startups that eventually have very tight collaborations with these industries. Now, in order to further strengthen the cycles that we have here, we created about 5 years ago Robotics, the Center for Robotics, where it's many groups at ETH that are doing robotics and related research. And this is supported by ETH on one side. We are essentially transforming the old machine laboratory into the new robotics playground, where we can make outreach activities, talk to the industry, talk to the general public, have people really working together. But I think most importantly for this event, we created frameworks that are composed of different layers of how we collaborate with industry. On the very top level, partnership programs together with industry, where industry helps us in shaping the right research directions, where they get really a saying, where they can work with us, fund research programs, and even professorships. We have individual research connections, research programs between multiple faculties at ETH and individual corporates, just as we have seen before in the Microsoft case. And last but not least, we are creating a community program, which essentially allows all of these companies to get a much closer insight in what is happening in research at ETH. With this, I'm at the end. I'm happy to discuss this further afterwards. And for those that are interested, join us at the Open Life Day and see these robots in action. Thanks a lot.
As principal data scientist, our next speaker, Saurabh Bhargava, leads several industry collaborations in the innovation department of the Swiss Data Science Center, a joint venture between ETH and EPFL. Saurabh studied at both universities as well as at the Indian Institute of Technology in Roorkee and has worked longer in the industry in big data. where he developed and industrialized various data products for the retail and advertising industry using state-of-the-art tools and cloud infrastructure. He now explains to us why the SDSC is a leader in AI innovation in Switzerland. Please welcome Saurabh.
Good morning, everyone. Welcome to my talk, which is about the Swiss Data Science Center, which has been leading the AI innovation in Switzerland since 2017, when it was when it started in 2017 as a strategic focus area of the ETH domain. Since then, we have grown up to more than 130 data science professionals, and we are supporting in the entire data science journey of academic institutions, public sector, private sector, and also the hospitals. At the moment, as I said, we have grown up to apply our research and our innovation in industry. We are now more than 130 research professionals that are distributed across 4 teams in 3 locations, Zurich, Lausanne, and at PSI. And we provide core services, full stack, from applied research to innovation in industry, making business impactful data products for companies. We also provide some engineering and open research data services to the companies. Just not to forget, we have our core services that are distributed across a horizontal of various sectors, but we also have our domain-specific services. For us, it's very important to stay focused on our verticals that are into the energy and sustainability sector, into climate and environment, digitization of public sector, and also health and biotech. And in order to give you a taste of what we have done in the past, here are a few examples. So in the manufacturing sector, we have been collaborating with the Bühler Group based in Uzwil since 2019. We have worked on multiple projects with them, including digital twins. And one of them here I wanted to show you is optimizing milling plant component settings. So you have multiple settings of the plant, which you can tweak with the help of the past data in order to minimize the energy that is spent. So you can save a lot of money by saving the energy costs. I led the project with the Adecco Group, which is a big recruiting firm, where we help them match the job profiles to the right candidates using AI. One of the projects where I also worked since last 2 years is with EKZ, the energy service provider. And we worked on multiple projects, also from bringing the project from advanced POC to industrialization phase. One of them was about making efficient solar panels. So solar panels, over the period of time, have many problems like deposit of the dust or shading effect. And we wanted to detect that in advance so that you could basically prevent the loss of power that is being generated and hence improve the efficiency of the plants. Not to forget, we have been working also with luxury sector like Richemont, where we help them allocate luxury product to the market based upon the demand. And pharma, as I said, is also a very important topic for us. We have worked with Lonza and Merck. With Merck, we help them predict adverse effects of tumor drugs. So yeah, with this, I want to show that our collaboration is not limited to these companies. Rather, we have a broad landscape of collaboration. Just to give you an overview, with manufacturing sector, as I said, we work with Bühler Group. Recently, we started working with Johnson & Johnson in a manufacturing field. We have worked with Schindler, Michelin, also perfumery industry, DSM-Firmenich. Energy sector, which is another vertical of ours. We have worked with Roman Energy in the past, with a running collaboration with EKZ and Bundesamt für Energie. With health and biotech, we have not only supported big pharma companies like Lonza and Merck, but also supported smaller companies like San Filippo Foundation that has been working in developing drugs for San Filippo disease, and also with hospitals like CHUV, City Hospital of Lausanne. Last but not least, we have worked with the public sector, Canton of Luzerne, Canton of Vaud, and City of Burgdorf on an InnoSwiss project, because InnoSwiss is also another way in which we can collaborate together, and some private startups that couldn't afford the prices, so we have worked with them enormously on InnoSwiss projects, and I was with one of them, Brunata AG, that we worked together with Stadt Burgdorf, and we delivered the project from end to end, from advanced POC to a working model that the companies can use for the benefit of them. Yeah, that's mainly it, and I just wanted to thank the organizers for giving me the opportunity to present Swiss Data Science Center. If you have questions and you want to learn more, please feel free to come to the booth number 120 later on. Thank you so much.
Dario Rusli is COO and co-owner of the ETH spin-off Dynius LLC. As COO and project manager, Dario helps define the Dynius strategy and is responsible for the coordination and implementation of Dynius's AI projects in Switzerland, Italy, and Germany. He previously worked mainly in IT consulting, but also in marketing and reporting at KPMG, Credit Suisse, and Autos. Dynius offers customized end-to-end AI implementations for small and medium-sized companies in various industries. Please welcome Dario, who will tell us more about this in a second.
Good morning, everyone, and welcome. AI is all around us, and I think by now everyone here in the room knows that. But did you know that AI can count and identify bacteria? Well, we implemented a solution that can actually do that. And I want to show you that in the next 4.5 minutes. But who is we? Dynius, or Dynius if you say it in English, we are the AI implementation partner of choice for you if you are a small company and want to automate your processes internally. We are very proud to be an ETH spin-off and also an affiliated partner or an affiliation with the ETH AI Center here in Zurich. We focus mainly on process automation of processes which are tedious, error-prone, and time-consuming. And here we go. I would like to show you very quickly what we did in this use case. So the initial stage was that we were approached by a laboratory in Italy, a biolab, and they showed us their most challenging process. Not challenging in terms of what they needed to do, but in terms of it was very tedious and it was very time-consuming. So it's the bacteria identification and counting. So how does this work today? Basically, the lab gets a sample of their clients, and they need to analyze the bacteria in there and also count the amount of bacteria in there. How they do that? They basically grow the sample on a Petri dish, standard process, and then they look at that at the Petri dish on a microscope, as you can see here in the picture. And the human being then needs to look through the microscope and count each of the colony, and then also identify them and sign how many of them are there in the sample. As you can imagine, this is very tedious, very manual, very time-consuming, and also very error-prone. As you can see here, they mark with a color each of the different bacteria, and you can imagine how difficult it's going to be to do a recount, right? Because it's already there. The output is a Petri dish, an original one, with the dots already there. So we thought about an AI implementation that could take over this task. So the input is not anymore a human being who is watching the Petri dish through a microscope, but it's actually a 4K high-resolution photo of this Petri dish through the microscope. We then run a computer vision algorithm to make, first of all,
object detection. So as you can see here, on the picture, you have the small bounding boxes around all the different bacteria in order to identify them. And then we run a classification model in order to classify these different bacteria. And I think a very smart move here was not to do a multinomial classification model with a lot of classes, but what we did instead was that we have multiple binary classification models that actually can do the classification. I think this is very cool because you get a labeled data set on a photo, you get the confidence interval, and you also get the number of the bacteria. You can just check that as a human being, and you don't have to do the counting yourself. And another very cool feature of that, of course, as every AI feature is, it can learn, right? So in the beginning, it might make some mistakes, but as soon the person who is checking the Petri dish and says, okay, no, you did this wrong, or you did this right, the system learns and gets better. And this is actually the biggest advantage of this AI solution that we have. And it's not in production for a long time yet, just a few weeks, but we have already saved more than 50% of the time of the people who do the work. And we have reduced the manual workload of 70% and more. That was already it. If you're interested in learning more and in seeing the application live, please come to the booth of DNews later on. And yeah, thank you very much for your attention.
Thank you so much. Thanks, Benjamin, Marco, Surab, and Dario. Okay, and we now turn our attention to the second focus topic, which is health and food. To set the stage for the upcoming case study, we've also prepared a short intro video for you. The researchers will walk us through their work and share insights in how equipping implants with electronic functions enables the detection of post-operative complications. So here is the case study with the title Smart Spine Implants.
How can we increase the success rate of spinal fusion surgeries? Spinal fusion is one of the most common procedures in spine surgery. Unfortunately, it comes with frequent post-operative complications. Many of these complications could be mitigated with early detection, so there's a need for a quasi, continuous and post-operative monitoring. In response to this, ETH Zurich, Belgrade University Hospital and 41 Medical as an industry partner are collaborating in an inner-Swiss project to develop a smart implant system for monitoring the healing progression after spinal fusion surgery.
Our research group at ETH specializes in ultra-low power microelectronics for the Internet of Things. Our task in this project is to take the force measurement inside the spine, convert it to a digital number, and transmit the data to a device outside of the body. The main challenge in this is the small form factor that the electronics and the battery are required to have. The power and data is transmitted wirelessly via an antenna implanted below the skin using near-field communication NFC.
The smart spine implant is designed to measure the forces that act on the fusion construct continuously over the first 6 months following the surgery. Under normal healing conditions, these forces are expected to decrease gradually as biological fusion progresses. Any deviations from this expected reduction in force can indicate complications such as the onset of screw loosening. This can enable timely intervention that can significantly improve the success rate of the treatment.
And now let's welcome Nicholas, Tobias, and Taekwon. Please join me on stage for a short discussion. Hi. Please. Good morning. So this is an inner-Swiss project. The collaboration brings together expertise from the Belgrade University Hospital and OR. Okay, so I guess managing a project that bridges different disciplines like medical, engineering, industrial, academic I guess that can be challenging. So Tobias, how did you manage a project with such interdisciplinary partners and ensure smooth collaboration?
I guess primary success factors for such a project are to have well-aligned goals and to have an open environment for efficient communication. And we achieved this first by ensuring that all project partners provide detailed input during the design phase, which helped us to establish a comprehensive set of requirements and milestones and a feasible time plan that everybody agreed on. We hold regular meetings at different levels, and we use collaborative tools to track our progress and identify issues early on. And we try to foster an open environment where all team members are encouraged to challenge assumptions or preconceptions, which helps us to continuously improve.
Sounds fantastic. Okay, so Taekwang, how does your research benefit from industrial collaboration in this particular project?
Oh, okay, so the biggest part for us is really the problem definition, meaning as a researcher in university, what we are shooting for to achieve is looking at what's the best technology available in IC design, what we are working on, and try to improve the state of the art beyond that. But the thing is, as a member of engineering community, our responsibility is really developing a technology that benefits society. And in doing so, industry partner is a perfect chance of understanding what market need is. In other words, what people need, and then we are developing technology according to that, and also we are finding an application space where our technology can help the people better.
With many options on the market, it's always crucial for new innovation to set themselves apart. So Nicholas, how is your smart implant different from the existing solutions on the market?
Yeah, so I'd like to compare the smart spinal implant to the current practice in the clinics. As of today, the follow-up after spinal fusion surgery is performed by X-ray imaging and CT imaging. So the patient has to go to the hospital, and then a snapshot is performed to evaluate the healing progression. But this leads to a problem because complications are often detected late or even remain undetected. And the smart spinal implant could address such problems by continuously and objectively monitoring relevant parameters and making them remotely accessible to the physician. A smart spinal implant could also prevent such complications in advance. For example, if a patient is too active too early, this could lead to implant failure and screw loosening, for example. Or if a patient is not active enough, this can lead to pseudarthrosis, which means that the healing doesn't work like it should, and this can also lead to a delay of treatment and delayed time to work. And this could be addressed by such an implant because the physician can immediately give advice to the patient to change the rehabilitation.
Fantastic outlook. So, Taekwang, let's talk about challenges. With which scientific challenges in this project you had to work to push also your research forward?
Oh, I see. So for implantable devices, usually the critical challenge is really the power consumption and accuracy need because of the small form factor. Meaning the sensor, the millimeter scale sensors, has pretty low sensitivity. They generate a very low amplitude of signals, microvolts, very, very tiny signal. So our IC has to be very accurate. At the same time, the battery capacity is fairly small, so we need to consume very small power, order of nanowatt. So this is where we're specializing at. What we develop as an IC solution for such as sensing, data communication, and processing environment, we could make those millimeter scale devices while consuming nanowatts of the power, but the precision is much, much higher, several orders of magnitude better than what's available for the off-the-shelf solutions.
So finally, your innovation has the potential to make a huge impact on patients' lives. So what would be, let's call it your call to action for potential industry partners, maybe sitting here in this room? Taekwang, you first?
So maybe what I can say is that these wearables and implantable biomedical systems, these have huge potentials in improving the human life and a very large market size that benefits human. And in doing so, I see it's a very critical solution because they are much order of magnitude better than conventional off-the-shelf components. At the same time, it needs a collaboration with the industry because it involves lots of other complications, including the biomedical testing, packaging, and other communications. And in this way, we need lots of collaboration with various industry partners. So look for us if you are looking into any solutions to that type of problems.
That was fantastic. Nicholas, do you like to add something on that?
Yes, so today we are talking about AI and data, but why are we not using orthopedic implants to generate data? If we could use such data to improve the patient lives afterwards and maybe also reduce the burden on the healthcare system, we should do it. So this is really important. Because of that, let's turn passive orthopedic implants into smart active orthopedic implants. Let's bring together medical device manufacturers and other stakeholders. And let's improve the patient's life by that. Yeah.
Thank you so much for that strong statement. So, ladies and gentlemen, please get into contact with our panelists after their presentation in the break. Big applause for these three phenomenal researchers. Thank you so much. All right, and now it's time for our fast-paced pitch round in the field of health and food. So you've already know the structure. Each participant has only 5 minutes to introduce you to their research and innovative solution. This session will explore innovations like sustainable food solutions and breakthrough medical technologies. Let's dive right into it. The stage is yours.
Alexander Mathis is researching new ways of sustainable food supply with his Sustainable Food Processing Group. The food technologist completed his education in Germany and Australia and worked on bioprocess technology at Nestlé. Since 2016, as a professor at ETH Zurich and currently at the ETH Singapore Center, he has been pursuing a systems-oriented approach to food production that takes into account the entire value chain as well as environmental, economic, and social impacts. Please welcome Alexander, who now introduces us to some technologies for more sustainable, nutritious, and affordable food.
Yeah. Good morning, everybody. Thank you so much for the invitation to talk about technologies for more sustainable, nutritious, and affordable food. And before we do that, I would like to show you why we have to do that, for example. You can see here on the left our global planet arable land distribution, where we have 14 million square kilometers available. They are all used already, currently. 1/3 of them, that's used for the 3 major crops, wheat, maize, and rice. And 1/3 of the crops grown are used for feed, not for food. So we have significant challenges when we see now the future in front of us, where we have to produce more than 60 or 70% more food according to FAO. So how we do that? We can see here on the right the Nature Sustainability Expert Panel, which suggested here with great contributions from different disciplines, socio-technical bundles to transform our food system. What does that mean? Yeah, when we, for example, talk about food waste, we first maybe should think about how we avoid it instead of how we process it. When we talk about nutrition and health, we should talk to the consumers maybe to have a more healthier or more nutritious diet. And technology can be then leveraged in this context in a more successful manner. And I hope I can show you some examples of these solutions now. In the ETH Sustainable Food Processing Laboratory in the Singapore ETH Center, we work here on microalgae, specifically polyextremophilic microalgae. What does that mean? That's microalgae from volcano craters. They grow at pH 1. You don't have any contamination. You don't need to invest into advanced technologies to protect the microalgae from contamination. That is reducing capital expenditures, operational expenditures, and makes it more affordable. We go through the whole value chain here, and you can see the reactor outside the store also running. Then we add some technology innovations to extract in a gentle way nutrients of interest. We process them further to more nutritious and hopefully also more healthy food products, where we also collaborate with the nutrition, medical, and consumer science in Zurich and in Singapore. You can see a little hidden value chain on the bottom. That's our black soldier fly larvae colony, which we run in Zurich and Singapore and also in developing areas. I won't talk about that today, but feel free to pass by our booth and I can show you more about that. So how we can process microalgae in a more effective manner. Here we teamed up with Bühler and our ETH SFP laboratory, where we collaborated to grow cells faster. Single cells can be cyanobacteria, as shown here, green microalgae, it can be yeast, many others. Fermentation is a big topic currently, but currently it's too expensive. It's not leading to affordable food products in an impactful manner. And this technology developed at ETH, together with Bühler, is called nanosecond pulse electric field, where we can reach the final concentration of the single cell system faster. And that is improving the cost efficiency of the value chain. We use a lot, we don't use a lot of energy here, less than 500 joules per kilogram, and I think that can be a quite impactful solution. But what do we do then with this microalgae biomass, which can be protein-rich, up to 70% protein, with well-balanced amino acid profiles, vitamins, minerals of interest? Here we showed the first worldwide study to integrate that into a meat substitute, together with our ETH spin-off Planted. I hope you heard about them, quite successfully currently in the business, running already. We could integrate up to 50% yellow and white microalgae. Microalgae don't need to be always green. I have here some powders, which you can maybe also take a look on. And that was then demonstrating the increase of nutritional quality if you add them in a hybrid mode of the final product. Very often our meat substitutes don't have the same nutritional quality than the animal origin. And maybe microalgae integration can be here a successful application to increase vitamin levels, mineral levels, and other nutrients of interest. Yeah, that is a bit our value chain approach. I just touched very few examples of the technologies which we currently investigate. If you want to see our microalgae reactor here on the left, a 25-liter photobioreactor, just leave the store straight on 10 meters, and then on the right you can see our booth in 128 with Fengzheng and Fabian running the reactor and our students. Leandro, our first doctoral student, and me on the right can show you our nanosecond pulse electric field technology evolution from a laboratory scale to a successful commercialization called Gemini with Bühler now. Yeah, and this we use in our Singapore ETH Center Food Translation Laboratory, which now was even getting a new funding from the Jeff Bezos Earth Foundation of $30 million, where we can continue this implementation of the solution. And I would like to thank our lab in Zurich and Singapore and our partners from the ETH environment, the spin-offs, the academic partner, and multinationals for all the support. And you for your attention.
Our next speaker, Andreas Guntner, is an assistant professor and has headed the Human-Centered Sensing Laboratory at ETH since 2022. He is also a research associate at the University Hospital Zurich at the Department of Endocrinology, Diabetes and Clinical Nutrition, and co-founder of the ETH spin-off Olivian. His group works at the interface between chemistry, physics, and engineering to equip electronics with a sense of smell. Please welcome Andreas now, who will tell us about the wide range of applications of sniffer electronics from health to space.
Thank you very much, ladies and gentlemen. Every time when we exhale, thousands of different molecules leave our mouth, and they contain rich information on our health status. Our world is made of molecules. So at home, at work, when we consume food, in our car, and perhaps even in this room right now, we are exposed to different molecules that can be hazardous, toxic, threaten our health. The problem is we cannot see them. We can also usually not smell them because our nose is not capable to do so. And that's why we rely actually on tools to provide us the molecular information that is needed. The problem is, however, if we look at our modern electronic devices, they can see, for example, my smartphone, I can take pictures or videos, it responds to touch. It can also hear, it can even think, and also other advanced systems like drones, or we heard before about robots, they lack the sense of smell and taste. Unless people find very innovative solution, so for example combining some alive systems that can provide this olfactory. Otherwise we usually rely on laboratory technology that provides us then single point measurements. So from time to time we may get some chemical analysis with a delay, usually hours, days, or perhaps even weeks. Because these technologies rely on expensive laboratory equipment, they require trained personnel, and are, as a result, not available in a home setting, for example, to continuously monitor our health status, or alarm us from the exposure to different toxic molecules. So what we need are small, tiny sensors that can be integrated, for example, in a smartphone, in a headset, or can be used for networks to monitor hazardous compounds in our surrounding. And this is the mission of our laboratory. So what we try to do at the Human-Centered Sensing Lab is to design nanoparticles that can actually convert this molecular information into readable signals of electronic or optical nature. We design also surfaces, and we also model these interactions, so we try to understand also and optimize our systems, but we work at the same time also on system solutions to integrate them into devices that can then tackle some of our most pressing needs in society, for example, in healthcare by breath analysis or monitoring other compounds by sweat or interstitial fluid sampling, in food safety analysis, or for environmental monitoring. Our laboratory is not just focusing on pushing the limits of science, but our core mission is also to translate technologies into products together with industry, to really let society also benefit from it. And you can see here one of the examples. So our startup Alivion has also booth outside developed one of these handheld devices. This is a device that can monitor methanol concentrations, for example, in beverages, where it is a toxic contaminant, in biofuels or hand sanitizers. Together with this startup, we have commercialized this technology. It serves today customers in 27 countries on 5 continents, and tries to protect also human beings from intoxication. So if during the Christmas break you may enjoy some high quality, some fine Swiss spirits, for example from Fassbind, it's very likely that these spirits have been tested with our ETH originated technology for their quality. Now also for us, for our molecular sensors, sky is not the limit. Humankind tries to explore in the next decade space even deeper. So humans will be exposed to the harsh conditions of space for longer than ever before. And as a result, there is a high need for monitoring technologies that provide critical health information on demand. And this is a project that driven by our students that currently work on the next generation of such health monitoring tools that are integrated, for example, in a headset. So we hope also that these technologies in the future will soon be tested, not just on Earth, but also in space. So if you have any molecular sensing challenge of any kind, I would be very happy to discuss it with you. Otherwise, I thank you very much for your attention.
Pedro Beltrão is professor at the ETH Institute of Molecular Systems Biology since 2022. The Beltrão Group researches human genetics and aims to explain how cellular consequences of genetic variation influence health and illness, and to find out which genes or proteins to target for therapeutic intervention. Before joining ETH, Pedro has been working at the European Bioinformatics Institute, which deciphers big data to advance the life sciences, and at the University of California, a university exclusively focused on health. He is an advocate of collaborative research, also across disciplines, and will talk about tissue-specific human drug targets. Please welcome Pedro.
Good morning, everyone. Of course, as we walk around each other, we often realize how different we are from each other. And to some extent, those differences are driven by genetics. So there are mutations that are particular to each one of you that make us different. And of course, these differences are not just skin deep. So if you look inside our bodies, if you look at our hearts as a simple example, we know about mutations in DNA that cause subtle changes in its shape. And of course, and unfortunately, there's also some mutations that will make it more probable that some of us will have a heart attack in the next few years. And so we want to understand that, of course, but for that, we need to understand also inside these cells, so the cells that have about 6 billion cells in the heart. And if we look inside our cells, these cells are working through machines. These are our nanoscale molecular machines, these proteins, that do all the jobs that are required for life. As an example here, you see a machine that is responsible for trafficking cargo along these other proteins that's called a microtubule. And so these motor proteins are trafficking cargo along another protein that creates essentially a highway inside the cells. So these proteins are highly collaborative. They interact with each other. And over the years, we've been studying these interactions of proteins in the context of human genetics research. And so we've learned, for example, that proteins that interact physically together, if mutated, are responsible for causing the same sorts of diseases as one might expect. And similarly, we also have learned that proteins that interact with disease-causing mutation proteins are enriched in very successful drug target candidates. So in this way, we can predict plausible other disease proteins and plausible targets for drugs. And so, for example, in a recent project that we've done together with GSK, we were looking for groups of interacting proteins that we could associate with one of 1,000 human traits or disorders. And we could show that this idea could identify previously known drug targets and suggest new candidates. Because we're doing this across really large numbers of human diseases, we can say something about specificity. We can say that this particular process, these particular group of proteins, is involved in some diseases of the liver, for example, but not of other diseases of the heart. And so this tells us a bit about specificity and drug target safety. And so these ideas have been transformed recently over the last couple of years by a number of different innovations. So one of these innovations has to do with proteomics. So we work here at the Institute, we have these top-of-line machines. And one of these things that we've developed is a combination of proteomics and machine learning methods that allow us to identify how protein associations change in different types of cells. And this is really important because there's a mystery that we still don't understand very well. So we carry a mutation in our DNA. This DNA is in all of our cells, but somehow it only causes a disease of the brain and not of the heart, even though that mutation is still present in the heart cells. And so these tissue-specific protein interactions help us to address why is it that these mutations cause only some diseases of particular types of cells. The other innovation that you probably are all familiar with, which won the Nobel Prize in Chemistry this year, is the capacity to predict the shape of these proteins purely from their sequence. And so we've shown that we can use the same ideas to predict the shapes of proteins interacting together. And we can do this at the scale of the whole protein interaction network, so at the scale of the whole cell. And so by doing this, we can better say when a mutation in a protein is likely to alter how proteins can interact with each other, explaining why these mutations may cause specific types of diseases. So these innovations are recent, and we're in the process essentially now of scaling these up. So this is really the vision. I think we can take these technologies to try to understand exactly how a heart cell is different from a neuron cell, and that would help us to understand why is it that some mutations cause specific types of diseases. We can structurally model them at the atomic level resolution for the first time in our history at the scale of the human cell, which of course will be very important to understand the impact of these mutations. And we're looking for partners for the specific application areas, and in the future maybe launch a startup in this area. And with that, I'm happy to talk to you in the speaker's corner afterwards.
Our next speaker, Simone Botten, is the CEO and co-founder of ETH spin-off Hylomorph, a clinical stage pre-commercial health tech company. Simone holds a PhD in mechanical engineering from ETH Zurich and a Master of Science in bioengineering from Politecnico of Milan. A recipient of the Pioneer Fellowship, Venture Kick, and Venture Leaders Awards, Simone previously served as a project leader at Wyss Zurich, where he led Hylomorph from academic research to first-in-human trials in under 5 years. One of the benefits for patients they are aiming for is to prevent infection after heart surgery. Welcome, Simone.
Good morning, everyone. It's such an important time of the year for me to be talking about what I'm talking about today, because this week is the Antimicrobial Resistance Awareness Week by the World Health Organization. Antimicrobial resistance, for those of you who are not aware, it's the ability of bacteria to become resistant to our existing drugs. So that means that the more we use our existing antibiotics, actually, the more resistant these bacteria are becoming. So that brings us to a very critical situation. In fact, antimicrobial resistance will claim more than 5 million deaths, or actually we claim lives, 5 million lives by the end of the year. It's 1 person every 6 seconds, and it's meant to almost double in the next 5 years. So no wonder why the WHO has listed this among the top 10 global healthcare challenges. I want to talk to you about 3 projects that we're doing to try and do our part into this problem. And they all have to do with implantable medical devices. In fact, 1 in 10 people in Western world will receive at least one medical implant during their life. It's about 100 people in this event, 10 to 20 people among us in this room. And I'm talking about cardiac devices, neurostimulators, breast implants for reconstruction, pumps, insulin pumps, heart pumps, orthopedics, hernia meshes, gynecology meshes, all these sizable implants. They all have their intrinsic residual incidence of infection. And normally, the more complex the procedure, the higher the incidence of infection. And why does this happen? It's because this is state-of-the-art 21st century technology to prevent infection in the operating room. We normally do 2 things. We wear aseptic control measures, gloves, masks, coats, and caps to prevent contaminating the patients and the implant during surgery. And we give a load of antibiotics to our patients to hope that this may kill potential contaminants that have entered the surgery. But we think we can do better, because no matter how hard we try with this in this way, we cannot still guarantee that when patients go home, they will be fully out of danger. So we have created our first product. We call it Vesta. It's an envelope and patch system that we can give to doctors, and they can put it on top of implants prior to surgery. And we're able to deliver antibiotics and antimicrobial drugs locally and in a sustained way to bring down the incidence of infection. By doing this, we can reduce, or we can put 60 to 100 times less antibiotics and still being 2 to 5 times more effective. We bring in a lot of technology from various industry fields, and it's a brief mention as it is Industry Day. We have to dive into bioresorbable polymers manufacturing, 3D textile industry manufacturing, drug formulation, biochemistry, and industrial design, adapt them and combine them into this type of product. Another thing that we're working on, we call it Prima. It's actually an app that we can download it. It's available on the App Store and Google Play for doctors to give patients. So the patients would go home and they would be able to take pictures of their surgical wound after surgery at various time points. And we are training a machine learning model to detect early sign of infection with AI to alarm in case we potentially identify an infection. Turns out that the earlier you detect, the more lives you can save. An average Swiss clinic discharging about 300 patients could save 1 to 5 lives per year. And last but not least, the project that we have recently started, it's a consortium with another 14 institutions in Europe, academic and small medium enterprises. It's supported by the Horizon Europe framework. We call it Stop Spread Bed Bugs. And the goal is to develop novel antimicrobial drugs to combat exactly this antimicrobial resistance. We are leading the implant-related infection prevention. I want to thank my team. We are 10 people based here at Technopark Zurich. Half of us are ETH alumni. We coordinate more than 60 people across mainly Europe and the US in contract manufacturing, CROs, testing labs. So we do a lot of outsourced work. We collaborate with industry leaders in regulatory and the medtech industry. And last but not least, we work with clinical advisors who see infection on a daily basis. And without them, we wouldn't be able to do the job that we do. With this, I would like to thank you and all the supporters, including ETH. As I said, we are alumni and a spin-off ourselves. So thank you very much.
Fantastic. Thank you so much. And let me give you the information where you can find this mention at Speaker's Corner. It's extremely easy to find. Just straight ahead and next to the bar, okay? And behind me, you can see who will meet there. Okay. Auch in diesem Jahr gehören die Spark Awards ganz klar zum ETH Industry Day. Ja, wir sind noch nicht so weit, alles gut, der Puls kann noch ein bisschen unten bleiben, aber wir wollen natürlich bereits einen kleinen Vorgeschmack geben. So later today, just before we wrap up, we'll have the Spark Award ceremony. Let's take a look at the projects in the running. So these are the nominated projects, incredible innovations, and I think this alone deserves a big round of applause. Please, ladies and gentlemen. Thank you. So. Das war also ein sogenanntes Amüs-Bouche, um ein bisschen Appetit auf mehr zu machen. Now we've reached our break, but we still have an exciting second half ahead of us covering materials and processes and sustainability and construction. And now let's enjoy the exhibition exchange with our speakers. And please be back on time. Genau 11 Uhr geht es hier weiter. Also, bis nachher, einen guten Kaffee, bis später.